Hello viewers, how are you? Welcome to Experience Learning. So today we are going to discuss about you can see the four pillars of object-oriented programming language. As Java is object-oriented programming language, we know that we have to discuss about this and why the procedural language and the developer shifted to object-oriented programming language. We will also discuss about it. Okay, and this is mainly beneficial for the students, BTech students and code lover. Those who are just thinking that I want to learn Java, for them also. Okay, let's start. And please subscribe the channel. So I am starting from the concept encapsulation. If we think that procedural programming language, that time what happened, I guess you know that most of the time the datas are, it's actually written in terms of data as well as function. The main concern is the data and function. If the problem is given to you, you have to think about that what will be the data and how the function will be written. But we are not just thinking about except this, but in real world, whatever we are getting, everything is object. If I think that the pen, this is one object. If I think that fan light, whatever, these are the object. If I am giving the example of students, so one student, I am telling you the student XYZ. The name of the student is XYZ. So this XYZ is an object. So everything in real world, it may be the car, sun, moon, students, employee, whatever. So these are the form of object. Not always not necessarily that will be a touchable. It can be the concept. It can be intouchable. But still the object, it's not only data, not only the functions. This is basically the combination of both. Have the behavior as well as the, attributes. If I am considering the pen has the attribute, the color of the pen, the features of the pen, and the behavior. When I am just writing this, it will give some mark. The mark is black. These are the behavior. So I think from this you are getting that what is object. So the main pillar of object-oriented programming languages, that encapsulation, abstraction, next polymorphism and inheritance. So I'm going to discuss it one by one. And one thing I want to share, that in case of procedural language, say for example, I am giving the student data, and here the student data have a roll number, marks, name, obviously the name. All of this will be, you can make it in the structure, and we have some functions. Say F1 function for giving the marks, and F2 function is for giving the roll number, and F3 function is displaying the name with marks, and F4 function is for name and roll number, like this. So functions are written in this way. So you have to make the structure global, otherwise how can we access it? And if it is global, and so the struct, if it is global and maybe there are some other function, F5, F6, so this function is not actually related to the students, but still the misuse, it can misuse the data. So the security in that sense is not very strong in case of procedural language. Now what is encapsulation? Encapsulation is a process which capsule, you know that a capsule, the doses are actually in there. So encapsulation is data as well as the associated methods are wrapped in a single unit. This one is known as encapsulation. If I am thinking that say for example animal. Okay. So I can write that some attributes, maybe the class of animal, and some behavior is sounds of the animal, like this. Okay. So this is encapsulation, when the attributes, the number of legs, the number of eyes, and all like this. I'm just taking. So when the attributes as well as the behavior, how it's eat, behavior wrapped in a single unit, this one is known as encapsulation. Okay. Next pillar is abstraction. So what is abstraction? So from the name, I think you can already understand it. When you are listening to song, you are what I am telling, say you are listening to song in your mobile or maybe in other device. So that time you are not interested that how it's stored and how it's playing, or like this. So you are just listening to it and without knowing the background details of it. Or if one person is driving the car, he knows that how to drive, but what is the background, I mean how the mechanism of the car and all like this. This is not, he is not actually, or she is not actually interested about it. So the abstraction is just like this, retrieving the essential details without dealing with the background details. This is abstraction. Generally in real world, the abstractions are in 3 levels. One is physical level, next one is conceptual level, and last one is a view level. Say for example, if you say you go in a bank and you just ask that you want to see your details of your account. So there is the data, how it will be stored in the machine, how it will be stored in the server. This is no, you are not interested about it. So how it is stored, this is a physical level abstraction. And what are the data, how the data is entered into it. So this is a conceptual level abstraction. And view level abstraction, maybe the total, the details of you, the customer ID, CID, CNAME, your account number and phone number, address. So the employee, where you go actually, the employee can only see your name, ID, account number and the balance, not the phone number and address. He is not allowed to access this one. And maybe when you go to the manager can see all of this. So these are the view level abstraction. Which portion allowed to see? Okay, so I think you are getting what is abstraction. This is the main concern. The abstraction is when we are actually retrieving the data without knowing the background details. So when the object-oriented programming language is written, the user just going to use it without knowing the background details of it. Next one is the polymorphism. So polymorphism, process of representing one form in many forms. Say for example, you know about in your school level concept, that the concept of thermostat. You can use the thermostat in fire alarm. The thermostat can also be used in our ironing our dresses and whatever the iron, and in any electric heater where the control is needed, that overheating will not be allowed. So the thermostat, this is one thing, and it can be used in many forms. And you can also think that you, when you are a student of XYZ college, you are an engineering student, and so then you are a student of that college, and you play guitar very well, so that then you are a guitarist, or you are a singer also. So you single one, but in many forms. So this is the concept of polymorphism. In object-oriented programming language, there is two types of polymorphism. One is runtime polymorphism, another one is compile-time polymorphism. I'll surely discuss about it later. Okay, just for now, the polymorphism is this one. You can also make a note of it. So the compile-time polymorphism, which will be decided in compile time, and one of the example of compile-time polymorphism in Java, function overloading, and next one is a runtime polymorphism. The example is function overriding. So remember that function overloading is compile-time polymorphism, function overriding is runtime polymorphism. Most of the time you can get the question in your MCQs exam also. Just keep it in your mind and you can make a note of it. Inheritance is writing the code when you're writing the code, that time one class inherit, that means get some property from the parent, or you can say from the base class, and a class which will be written, it may have some own features and behavior also. Say for example, you are getting some books from your seniors, so you are inheriting it, and you may buy some other books also. So here this is the concept of inheritance. Inheritance features are from one class to another class. Okay, taking the features from one class to another class, and class which giving the features is known as base or parent, and sometimes known as superclass also. And the class taking the features is known as derived child or subclass. Okay. Say for example, I am giving you, taking animal class, and name of the animal, color. Okay, then walk, sleep. Okay, so these are the common features of animal, and now from this I am creating another class, say for example cat, and name, color, legs. Not necessarily all the animals will have legs, so the legs features can be added in cat, and another, say, the sounds. So here the cat will inherit these attributes, that means name, color, this attribute also, and the behavior walk, sleep, this behavior also, as well as it has its own attribute legs, and the behavior sound. So I think you can understand what is inheritance. Inheritance is when you are actually inheriting some property from your parent. And what are the advantages in case of object-oriented programming language? Redundancy of code reducing. You cannot, no need to write the code. Say you are taking the name of the animal. No need to write it in cat class. You are taking the color. You are taking the color of animal. No need to write it for the cat class. So you can reuse it. So reusability of code is allowed, and obviously application development time will be less. When you are allowed to reuse the code, the application development time will be less. There are multiple types of inheritance there. This is one of the example of single inheritance, multi-level inheritance, hierarchical inheritance. Okay, I will discuss it in later video. Today I don't want that it will be very longer. But one thing you can remember, that multiple inheritance is not allowed in Java. It's allowed in C++, but it's not allowed in Java. Okay. So apart from this the primary features of object-oriented programming language, these features are also there. One is message passing and another one is dynamic binding. I can give the number as 5, 6 here. So what is message passing? You can understand this when you are writing something in your WhatsApp or you're sending message. Nowadays generally we don't send message. Most of the time we write it in WhatsApp or any other using the chat actually. So message passing is just exchanging the data between multiple objects. Say customer is one object and bank is another object. So there will be obviously some meaningful operations, and the customer request for withdraw balance, withdraw some money. So get money, we can write a function like get money. So customer number and withdraw request is sent to bank, and bank responds it giving the account number and present balance, because after withdrawing it, if the bank allowed to withdraw it, so it will just send back to customer the current balance in that account. So this is a concept of message passing. And then next one is a dynamic binding. So what is a dynamic binding? Dynamic binding is a mechanism of binding an appropriate version of a derived class. So what is the appropriate version of the derived class? I have already discussed in the previous, you can just rewind it and you can see that animal class and cat class was there. So appropriate version means obviously that in general the walk function of animal will not be exactly for the cat. That means in general the for which the animal walk will be written, the behavior of walk will be written or sleep will be written, that will not be exactly the same one as for the cat also. So cat can have its own version for walk and sleep. So this is so here we can get that binding of an appropriate version of the derived class which is inherited from the superclass. That means the previous example I have given you, that the animal class and with the base class and with the base class object. So when which one will be called? Say there is one function is walk written for the animal class and one function walk is written for the cat class. So when which version will be called, that depends on this, the creation of object and all other things. I will discuss about it later when I am going to discuss about the runtime polymorphism actually. Then that time I will also discuss the dynamic binding also. Okay, just now I am just giving you the overview of the features of it, and obviously now I am going to give you the main things, the basic things, the buzzwords you can say. Class and object for every object-oriented programming. So what is class and what is object? I am going to discuss about it now. So what I am telling that the main things in object-oriented programming language is class and object. So what is class? Class is binding the data and associated methods in this way. That means a class is basically the concept. It's a blueprint. For example, if I am saying that box, you know that there is a concept that it has a length, breadth, height, maybe the color of it, and the behavior, obviously what will be the volume of it, and the texture of the box, outside of the box and all. Is it solid or you can it's not. So all these this is the class, the concept, the logical one. This one is known as class. And what is object? When the actual one or the physical instance of the class is created, then this one is known as object. For example, I have already given you the example. So student is a class, have the attribute. The class has basically the two parts. One is the attribute and another one is the behavior. So here the attributes we are getting the length, breadth, height, and the volume is a behavior. So this is not the object. But whenever I am saying that red box or that wooden box, so that means you are particularly saying something. So that is the physical instance of it, and this is object. And what is object? We can see that the instance of class is object, and you can say the entity is known as object. So when I am telling that the employee class, and when I am telling that employee with the employee 1107, that is the ID of the employee. That means that 1107 employee is object, but the employee is class. Okay. And in case of Java, I have just written, try to write the difference between the class and object. What is the class? Class execute in Java program, when execute the Java program, class will be loaded into main memory with class loader subsystem. I have discussed in the previous video that what is class loader in JVM and all. Please see this first. So the class loader subsystem will load the class, that is a concept, in main memory. Okay, but it will be once. This is very important. This will be loaded once. But the object, there can have n number of objects. There can have n number of objects. So for example, when I am writing that the box, red box. Okay, so this red box is the object, the variable, the class variable. You can also say that this is a class variable. Now see one thing, when the class ID defined, no memory space of data member. So whenever you are writing the red box, that means the, say you are writing the block box, red box. That time this red box is actually null. This is actually null. It's not allocating the memory. But whenever you will write, I am writing the Java syntax actually. Red box equals to new box. So that time it is actually able to get the memory space. From where it will be allocated? From the heap area. So where the heap area is, this is also discussed in the previous lecture, the JVM architecture. So whenever you are writing that the new box, that time the red box object will allocate the memory for which? For the data members. So here it is length, breadth and height. So if you are creating n number of objects, for each object it will allocate this amount of memory from heap area. See this, from heap area. Hope you can understand this. If you have any problem, you can write it in comment box. If you like this video, please press the like button. And thanks for watching. Please subscribe the channel.